Welcome to all. I am Part-7. I am going to present about cooling humidification and cooling dehumidification and heating humidification and heating dehumidification and sensible cooling and sensible heating, also discussing from this presentation. The first one is sensible cooling. When the air is passed over a surface with the temperature less than air dry bulb temperature, it undergoes sensible cooling. It is achieved by passing the air over evaporator coils. In the schematic diagram is shown that air in and air out. In between the cooling coil is located inside the duct. While entering the air from the atmosphere, it will be capture the cooling effect from the cooling coil. In order to change the environment air cooling effect into comfortable air cooling effect, after that the air out will leads to the exit of the duct, and that right hand side the psychometric chart will provide the dry bulb temperature value as well as enthalpy of the different temperature point, as well as that vertical line will provide the W values. The cooling and dehumidification process will be similar to that previous sensible cooling process. There will be some difference. Here the temperature of dry bulb temperature less than the dew point temperature, where the number 1 represented that air inlet and 4 represented that air outlet. The cooling coil is located in between the in and outlet of the air, and then the psychometric chart will provide that dew point temperature and dry bulb temperature, enthalpy, ADP, adiabatic process, and delta W, and the vertical axis provide the W value, and then change in dry bulb temperature also obtained directly from the psychometric chart. The cooling and dehumidification, whenever air is made to pass over a surface through a spray of water that is a temperature less than dew point temperature of the air, condensation of some of the water vapor in air will occur simultaneously with the sensible cooling process. Then cooling and humidification process, where if unsaturated air is passed through a spray of continuously recirculated water, the specific humidity will increase while the dry bulb temperature decreases. This is the process of adiabatic saturation or evaporative cooling. In the bottom figure is shown that psychometric chart of cooling and dehumidification process, where in the enthalpy line will provide the different dew point temperature value, and then we can able to find out other character from the psychometric chart at the midpoint of the dry bulb temperature and the enthalpy line, and as well as that W value also obtained from that vertical axis. The heating and dehumidification, if air is passed over a solid absorbent surface or through a liquid absorbent spray, simultaneous heating and dehumidification is accompanied. The heating and dehumidification, if air is passed over a solid absorbent surface or through a liquid absorbent spray, simultaneous heating and dehumidification is accompanied. In order to find out the WA value at 1 and 2 from the psychometric chart, if you have enthalpy and dry bulb temperature corresponding between the 2 points, we can able to find out all other parameters from the chart. And then heating and humidification. If air is passed through a humidifier which has heated water sprays instead of simply recirculated spray, the air is humidified and may be heated or cooled. In such process, the air increases in specific humidity. The enthalpy and dry bulb temperature will increase or decrease according to the initial temperature of air and that of spray. Here, the psychometric chart also provide the heating and dehumidification value by dry bulb temperature with respect to enthalpy. From the meeting point, we can able to find out that remaining values in the heating and humidification process. So this is the problem where we can find out the capacity of heating coil, amount of water vapor removal per hour, capacity of cooling coil in ton of refrigeration, and also we can find out the humidification and dehumidification value of air. From 5 in the an office is to be air conditioned for 50 staff when the outdoor conditions are 30 degrees Celsius. Dry bulb temperature and 75% RH is nothing but rehumidification if the quantity of air supplied is 0.4 meter cube per minute per person. Find the following required things. First one, capacity of the cooling coil in terms of refrigeration, capacity of the heating coil in kilowatt, amount of water vapor removed per hour. Assume that required inlet conditions are 20 degrees Celsius. Dry bulb temperature and 60% rehumidification. Air is first conditioned by cooling and dehumidifying and then by heating. Because from these conditions we have to find out the required values. First of all, we have to find out the value from psychometric chart. At 30 degree Celsius dry bulb temperature and 75% rehumidification value, the H1 value obtained as well as the Vs value also obtained. At dew point temperature 12 degrees Celsius, the H2, the enthalpy at second condition is also obtained, where the dry air is provide that enthalpy value. At 20 degrees Celsius dew point temperature and 60% rehumidification value will provide H3, the enthalpy at 0.3 value, capacity of 50 staff. So volume is equal to 0.4 meter cube per minute per person. is equal to 20 meter cube per minute. So mass of air supplied V1 divided by Vs1 is equal to 22.47 kg per minute. The capacity of cooling coil is equal to Ma multiplied with H1 minus H2. Capacity of heating coil Ma multiplied with H3 minus H2. Amount of water vapor removed is also calculated from mass flow rate of air multiplied with W1 minus W2 multiplied with 60. So we can get 16.18 kg per hour. Then thanks for watching this video. In this I will conclude this presentation. This continuation will be come in the next part.